Hi guys, this is Alan from Miss Wade's 7th period calc class, and right now we're going to do number 13 from the part A, no calculator part. So, reading through the problem, we have the region bounded by the x-axis and the part of the graph of y equals sine of x between x equals 0 and x equals pi is separated into two regions by the line x equals p. At the area of the region for x is greater than or equal to 0 and less than or equal to p exceeds the area of the region for x is greater than or equal to p but less than or equal to pi by 1 square unit, then p equals blank. So then we have our 5 answer choices here. Okay, so let's write out what this problem says kind of in math terms so you guys can kind of see what's going on here. So first of all, we have y equals sine of x, right? And this is going from between x equals 0 and x equals pi. Okay, I think I can rewrite this. There we go. X equals pi, okay? And it's separated into two regions by the line x equals p. So let me pull up a graph here. If we have y equals sine of x between x equals 0 and x equals pi, we see that our domain is basically restricted to this area right here. So this is all we're focusing on. And of course, finding the area underneath this curve basically is going to be between the x-axis and this graph. We're just going to use an integral for that. But it's saying that there's a line x equals p, which will divide this region into two regions. It'll divide the area under here into two regions, with one of the regions being 1 square unit bigger than the other one. So pretend like we had a line x equals 2. This region left of x equals 2 and underneath the curve would be 1 bigger than the region to the right of it. But right now we don't know what x is. We don't know what p is, sorry, at that time. So we're going to try to solve for that right now. Okay. So it says, so let's interpret this part into math terms. So if the area of the region from x is from 0 to p exceeds the area of the region from p to pi by 1 square unit, what does that mean exactly? Well, if you write this out, it's basically saying that, so the integral from 0 to p, so that's going to be the area for there, of sine of x dx, is going to be equal to the integral from p to pi of sine of x dx plus 1. Okay, because the area of x from 0 to p is greater than the area from p to pi by 1 square unit, right? So that's what that means right here. We also know that the integral from 0, actually I can copy this down, but we also know that the area from 0 to p plus the area from p to pi is the same thing as the area if we were to just do from 0 to pi, right? So we can actually plug in some of these equations here into this other equation. So this one, we have basically saying that sine of x dx from 0 to p is equal to this. We can essentially plug that in for right here, right? So if you copy this over, paste, and this is going to be plus this. So again, this part represents this part. And then, of course, we have this equals sine of x from 0 to pi. Okay? So now if you rewrite this part, we see we have 2 sine of x dx from p to pi right here. So we can just have a 2 out front and multiply that by 2. And then if we take this 1 and we subtract it over, we can see that we have now 2 times this equals this right-hand side term minus 1, correct? So now we can solve for this term and make it into a number. So then we can find out what this term is as a number. So again, this is no calculator, so we can't use a calculator for this portion. So we know that the integral of sine of x is negative cosine of x, and this is going to be from pi. Actually, it's going to be from 0 to pi. Sorry, and we're gonna include this minus 1 in a second. We'll put that on later. But so if you do it from here, we just plug in these values. So you have negative cosine of pi. Oh, that's weird. Why did it do that? Negative cosine of pi minus negative cosine of 0, right? So this can become a plus, but negative cosine of pi, if you guys look at a unit circle, it's just negative 1. So negative cosine of pi would be positive 1, and cosine of 0 is, of course, just 1. So this would become 1 plus 1, which equals 2, right? So that's just this integral part. We still need to include this minus 1 at the end. So after we do that, that just becomes 2 minus 1 equals 1. So this entire right-hand side becomes just 1, since this is 2 and that's minus 1. Okay, so we can rewrite this part now to include everything, and we can set this equal to 1 now, right? We can divide this 2 over, so now we have the integral of sine of x dx from p to pi equals 1/2. And now we can just do the integral of this part, but instead of having like plugging in a number, we would just plug in p, right? So we already did the integral of this above here, so we know that the integral is negative cosine of x, but this time it's instead of from 0 to pi, it's going to be from p to pi, right? So if we plug it in like we did before, of negative cosine of pi minus negative cosine of p. And this, as we showed up here, equals 1/2. Okay, so this is 1 again. This becomes just plus cosine of p, and then equals 1/2. So if you rewrite this, we have cosine of p equals negative 1 over 2. If we subtract the 1 over, okay. So we now know what p is equal to. Well, we're now close to knowing what p is equal to. We can use now a triangle, or basically if you have a unit circle memorized, you can use that too. But first of all, we should be careful that p is defined to be between 0 and pi, right? Because this entire function, this entire question is between those two parameters. So let's keep that in mind. So p is between 0 and pi. And we can also see here that the cosine of p is negative. So if it's between 0 and pi are quadrant 1 and quadrant 2, right? If cosine is negative, we know that this has to be in quadrant 2, right? Because quadrant 1, cosine, tangent, and sine are all positive. So we know that this has to be in quadrant 2, okay? So if all we need to do now is if we pull up a 30, 60, 90 triangle, let's do an image, 30, 60, 90 triangle. So cosine of p equals negative 1/2. So we'll just do the 1/2 for now. So cosine of p equals 1/2. We'll see that that's the 60-degree angle, or pi over 3. So cosine of pi over 3 is 1/2, but we're trying to look for negative 1/2, so it's going to be in quadrant 2. So instead of having pi over 3 in quadrant 1, we would have 2 pi over 3 in quadrant 2. So finally, we have 2p equals 2 pi over 3. And if we go to the questions, the answer is E.